Hello. This video is about the slope-intercept form of a line. We saw the equation of a line had two variables. In our case, here we have x and y. And these two variables, in order to make it linear, are raised to the first power. So they're really x to the first power, y to the first power. And that way I know it's linear. So we know that this particular equation, 2x plus y, has solutions in a specific form, has solutions in the form of ordered pairs, parentheses x, comma, y, and parenthesis. These pairs, when plotted on a coordinate system, Cartesian coordinate system, form a line. Now recall that we can find several points to this equation and plot them, or we can find the intercepts and plot those. So let's look at the intercepts just as a refresher, because we've done this before. So the intercepts, let's pick the y-intercept. And the y-intercept, hopefully you're envisioning a little Cartesian coordinate system over here, and you say, all right, y-intercept, all right, this is my y-axis. The line is going to go through this axis. Oh, that's right. It goes through the y-axis when x is equal to 0. So we'll put x equals 0 into our equation, and when we do that, you can see, I think, right away that we get y is equal to 6. This corresponds to a point, x comma y, right? X is 0, y is 6. That's the point. All right. Let's look at the x-intercept. Again, in your mind's eye or on a little piece of scrap paper, you have a coordinate system over here, and you say it goes through the x-axis, right, when y is equal to 0. So let's let y equals 0. If I put y is equal to 0 into my equation, I will get x is equal to 3, and I'll leave that up to you to verify. And this also corresponds to a point. X is 3, y is 0. All right, so I get two intercepts, 2 points, when I look for intercepts. Now the other thing we can do, let me write the equation down again, is we can solve for y. We've done this before also, but if we solve for y, I think you can see that we can just move this 2x to the other side, and it becomes negative, right? So we get y is equal to minus 2x plus 6. Now let's recall we had intercepts of x was 0, y was 6, x was 3, and y was 0. Well, notice if I were to put 0 into this equation, right, if I let x equals 0, this term goes away, and I'm left with y is equal to 6. So it turns out that this number right here, this number is the y-intercept. All right, let's graph this equation. So let me go to another page and graph this equation. All right, so here it is. Remember that we had an x-intercept here, and that was 3, 0, and we had a y-intercept of 0, 6. So I just plotted those 2 points and drew a line, and we have the equation y equals minus 2x plus 6 in orange. let's look at the slope. Remember, slope, m, that corresponded to slope. And we had words for this. We said, well, this is equal to the rise or the change in the y direction over the run or the change. Remember the little delta sign, change in the x direction. So let's take a look at what this is. If I start at 0, 6, I'm going to go 1, 2. I'm going down in the y direction, so my change in y is going to be negative. I'll go up to negative, well, if I go over to negative 2, oops, I don't know why this does this, but it does. Okay, so if I go to down negative 2, right? And then in the x direction, to get to the line, I have to go to the right, which is positive. So in the x, I have a positive 1. So it looks like my slope is negative 2. Let's try this a little bit with lines that go a little bit farther. Let's try, let's go from 0, 6 all the way to 3, 0. I can use the graph. 1, 2, 3, 4, 5, 6, of course. So that was negative 6. And the run would be 1, 2, 3, right? Well, that's negative 2. So that verifies, that's good. We could have used these points. Let's just do that for practice. Let's use the points. Slope is the change in y. So let's call this our first point, this our second point. So it's y2, so the y value here, 0 minus the y value of the first point, which is 6, all over x2, which was 3, right? The x value of the second point, minus x1, which is 0. And this gives me minus 6 over 3, which is negative 2. So I'm pretty confident right now, I've got 3 values of negative 2, that my slope is negative 2. Again, look at what's sitting in front of the x. The coefficient in front of x is a negative 2. That's interesting. I have a negative 2 sitting in front of the x. My slope, no matter which way I look at it, is negative 2. Also, my y-intercept is 6, and that's sitting right here, plus 6. There's no coincidence here. This is the slope. This is the y-intercept, and we're going to call it b. So it turns out that the equation in slope-intercept form of a line, slope-intercept, looks like this. Y equals m, the slope, times x, plus some number, b. That is slope-intercept form. You need to memorize this. You need to understand all the pieces of it. So let's take a closer look at it. I'm going to say y equals mx plus b. Oftentimes when you've learned this and you keep going, people will say, what's the equation for a line? And everyone says, y equals mx plus b. So if you're woken up in the middle of the night and someone says, what's the equation of the line? You should know what this is. And I don't know what just happened here. Hold on just a second. Okay. So let's look at our equation. Our equation was y is equal to minus 2x plus 6. And really, if you put it in this equation, in this form, you'll notice that everything lines up. The y lines up. It's not a negative y, it's just a y. The equal signs line up. M lines up with minus 2. X lines up with x. Plus with plus. 6 with b. Everything lines up perfectly. Let's try another equation. Let's look at something that's slightly different. Let's look at y equals 3x minus 1, for example. Well, how does that line up? Well, the y lines up, the equals lines up. The slope is going to be, that's right, 3. Not 3x, just 3. M is corresponding to this 3. X lines up with x. Right? So m is our slope and it equals 3. Ooh, there's a little bit of a problem here. I don't have an equal sign. I mean a plus sign. So let's rewrite this equation, the one in yellow. Y is equal to 3x. And if I add something, what am I going to add? Yeah, we've had tons of practice on this. I would add a -1. So now the plus sign lines up, and b is, right, -1. So in this equation, my slope, m, is equal to 3, and my y-intercept, which is b, this equals the y-intercept, that is equal to a -1. So let's graph this equation. Let's see if we can graph this. Let's see, -1 and 3. Let's go like this. So here's x, here's y. I know my y-intercept is -1, so here's -1, and I know my line goes through that point. It goes through this point right here. And now my slope is 3, so let's put a little bit of a grid here. 1, 2, 3, 4. 1, 2, 3, 4. Put a 1 here and a 1 here. My slope is a +3. So I could write that in rational form as 3 over 1. So now I know my rise is 3. So I'm going to start at this -1, and I'm going to go up 3. 1, let me do this a little bit bigger. 1, 2, 3. I know I go up because the 3 is positive. Then the run is 1, so I've gone up 3. I'm located right here, right? This is where I'm standing. So I'm like, hey, I'm over here. And I go over 1 to the right because the x is also positive, and that gives me my next point on the line. Then I can just draw the line. I have 2 points. I should be able to just draw the line, and there it is. The people are optional. All right, that's the slope-intercept form of a line. Very handy to use. You can see why we worked with rational numbers. It comes in very handy with slope, right? Rational form. You can see why we solve equations for y or for a specific letter, right? Remember we did all of those. You can see why we said addition and subtraction are related. So everything is starting to come together, and we're starting to be able to use it in a graphical form. Great.